Hey everybody, this is Larry. This is day 13, January 13th of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about this problem. And there are a lot of people there posting solutions and just chatting about readability and stuff like that. So come hang out. Okay, today's problem is minimum number of hours to burst balloons. Sounds hard, but it is only a medium, so we'll see how that goes. Okay, so there's some balloons. It has an X and okay, there's X start, Y start, okay, you don't know the Y coordinates. Hours can be shoot upwards, okay. Okay, there's no limit number of hours, okay. So you have to shoot every balloon, okay. Take a look at the constraints, there's 10 to the 5th, okay. Okay. So it's a little bit tricky to say because looking at the constraints, the intuition is that it's going to be a greedy solution and that it's going to be like a sorting analog n with a greedy type thing. And that's just from the 10 to the 5th. That's of course a little bit meta. And of course, if you're just on an interview with a random interviewer, that's not going to help you because they might not tell you the exact n. So okay. So there are a couple of, I actually don't know how to do this off my head. There are a couple of dots. One is, like I said, there's greedy, and with greedy, there are a couple of approaches. There's whatchamacallit, sweep line or line sweep is the one that if you watch my video from time to time, you know I'm a huge fan of. So so yeah. Let's see. Also, I hope my neighbor's doing some like vacuum cleaning, so I hope that's not too loud. If it is, my apologies. Maybe I should have done this video a little bit later, but yeah. Okay. So the key part about this problem is that it's not okay. I was gonna say it's not an optimization problem, but that's wrong, and that you have to minimize. But that's what that's what. but the thing about this problem is that you have to hit or every balloon. So because you have to do every balloon, there's no decision there, right? So then you ask yourself, when would I, given a time span, right? When is the when is the time I would burst it, right? Well, I think I have a sweep line idea. I have to think about whether this. I have to think about whether. I think the proof is harder for me with these greedy solutions or attempts. But I think that's the idea, right? Is that okay? You have these basically you have these line segments, and you have to kind of like cross them up, right? And then the idea is that okay, let me pull up Paintbrush really quick. So I could kind of draw out this idea. Normally I have pen and paper here, but of course I want you to see what I'm doing. That's probably why. So you have, but basically you have like this one, just number line, and then you have these like not line segments. Let me change the color actually. You have these line segments, and you're trying to figure out, in some way, like how to burst them all together, and they don't have to be like connected or whatever. Though it could be. And then the idea is that. So my first observation and thought is that okay, well, given like you have these constraints, let's say you're going from left to right, right? Terrible arrow. I'm drawing on the mouse. We're going from left to right, right? Well, if we're going from left to right, then the greedy thing to do is to not shoot until we absolutely have to, right? That's like the greedy way of approaching it, and what that means in more concrete terms instead of like English is that we'll shoot the latest that we can. So in here we will shoot here. Here we look at this balloon, we look at this balloon, we look at this balloon, and this balloon. But by the time we get to here, we have to shoot it because otherwise we won't get another chance to shoot this balloon, right? So we shoot here, and then now that means that we kill these 3 other balloons. And then in that same way, that means that we don't have to care about, you know, the end of this one or this one or this one and so forth, right? But yeah, I think that's basically the idea, is that okay, once we shoot this, you know, and we have to think about implementation for sure, but I think that's the idea, is that once we shoot this, we pop all these balloons and then we start over again, right, from left to right. And then we go, okay, this is good, this is good, this is good, and then we're here. Let's say this is a little bit before, and then we shoot this balloon, because otherwise, if we don't get this one again. So I think that's the idea and approach that I would think about, and I think that's good enough for me to get started. Yeah. And now we have to think about how to actually implement it, right? There are a couple of ways you can do it. You can sort. So the way that I would do it, to be honest, is using sweepline. But you can actually do. You can probably just sort by like the second component, right? The X end, and that should probably give you a good enough thing to do. Kind of. So yeah, I'm gonna do it with events and sweepline though. So then now we got, you know, from start and end and points is really what it's giving. We have 2 types of events. One is the start event, and yeah, let's just call it this for now. And in this case, we want to actually process the reason why how we choose these values is that it does end up being sorted by them, right? As a secondary, like a tiebreaker sort. And in this case, we do want the start event. So we want to process the end event after all the start events, because of the case that if there is a tiebreaker, let's come back to here for a second. If there's a tiebreaker of, you know, let's say we have two lines, and one starts here, and then at the same endpoint, you know, this begins, right? We definitely want to shoot here, but this here also overlaps with this beginning. So we want to process this beginning first. Hence, that's how we get the tiebreaker of, we want to process all beginnings at the same exact point before we do it. And of course, you can do it another way with, like, you know, inclusive, exclusive range type things. For now, I'm going to keep everything inclusive. We'll see what happens, right? Okay, so now we sort by all these events, and then now we just have to go through them. So for X, that's one thing that I wanted to do that I forgot. I was like, I feel like I'm missing something. But one thing that I wanted to do was also keep track of the index of the stuff that we're doing. So that, you know, I mean, you'll see kind of how I want to use it, but the idea is that once you pop a balloon, then you don't have to worry about it in later on, right? Yeah. So we begin by having a current set. Basically, it's not I said a set, but it doesn't have to be a set. I'm just using a list of current balloons within range, right? So for X, event type, and then the index in events. Okay. Yeah. So then we do current.append. Whoops. So if event type is equal to start, then we just append I. We don't actually use X, I don't think, because it doesn't really matter. Okay, and then now else if, and of course this is always going to be true, but then that allows us to do, maybe we could write it another way. So else we can do assert This is true, and it's something that I always recommend, so that if something comes up that's weird, you'll know about it at least in testing. Yeah, and then here we have to shoot this balloon, so that now, and everything that is in current will be popped, right? So here, well, the first thing we want to do is maybe we do add a thing called done. Maybe it doesn't have to be done, or it doesn't have to be a set. It can be a Boolean table, which is fine too, right? So here we go if done of I continue. That means that if we already popped this balloon, we don't have to shoot it, right? If it's already popped, we don't have to shoot up. That's the idea. So then we could skip this and keep going. Otherwise, we have to shoot the balloon and everything that is in current and will be popped. So then now we go for, I don't know, C in current maybe? Or I want to say I in current, but we always use I, right? So maybe CI for current index. Well, first of all, we set it to done. And I think that's it. And we have to do just one more thing, which is counting the number of shots. So count is equal to 0. And then count 1, and then just return count at the end. Yeah, I think this should be good, even though it's very awkward looking. But you can kind of follow through everything. I mean, we'll see if the test cases actually let me know it's good. And it does look good, so I'm happy about that. Let's give it a submit. Oh, I got it. I wonder what my code is last time. Hopefully I don't have some weird cases. Oh, time limit exceeded. Oh, I messed up. Yikes. This was, oh, huh. Okay. This is actually very lucky, but actually I was wrong. This code should not be working, but it actually happened to me. The one thing that I forgot to do is I forgot to reset it. Because once we set something to done, this is good. And of course, as you can see, it's not necessary. It's just that you're doing extra work because now you're setting it to done again. But let's say we do this, and then we could run it again, and this should be much faster. Yes, as you can see, this is much faster. Let's go with the complexity really quick. Sorry, I have like some sniffles, but yeah. But of course, as you can see from here, this is going to have, well, from here, this is going to be O of n space, and it follows through, it's going to be O of n space. Even current will be O of n space, O of n space, everything is O of n space, right? So we'll just say this is O of n space. In terms of time, of course, this is going to be n log n, or if you want to say 2n log 2n, which is n log n, obviously. In theory, at least for this part, in this part, this is O of n, because for every event, it only gets inputted into current once, and then it only gets popped from current once, so we do it all the popping at the same time, but we only pop from current once, and this is only this only happens once per input, and this also only happens once per input, so this is going to be linear time. And of course, this gets dominated by n log n. For kind of funsies, let's say we didn't have this, right, which is what we did by accident. That was a silly mistake. I knew it in my head, but I get distracted, I guess. I don't know. I'm very sloppy these days. But yeah, let's say this happens, right? What's the complexity? Well, this complexity is now n squared, right? Why is it n squared? Because let's say you have a case where, let's bring back paintbrush again. Let's say you have a case where it looks like this, right? Beginning end, beginning end, beginning end, no overlaps at all. The thing that what ends up happening with this no overlapness is that the first time it happens, once we get here, it will do one operation. And then the next one, because we didn't reset current, it will have 2 items. And then the next time it will have 3, and then dot, 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 all the way to n items. And this is, of course, roughly speaking, O of n squared, right? I mean, it's n times, was it n minus 1 over 2 or n plus 1 over 2? I always confuse which is which. But you get the idea, right? So that's why it is so much slower. And I'm just very lucky that I guess that is not a case in the input, because if it is, I would definitely been time limit exceeded very easily. We could probably construct it, but I'm a little bit lazy. So, but yeah, like you can write something like, actually we can construct it here, right? We can write points. Points is equal to the for x in range of, I don't know, even just 100,000 is probably good. And I guess that is the number though, right? So yeah, you could do something like points dot append x plus 1, something like that. That's actually a little bit different. It's not quite the worst case because I'm a little bit lazy, but like you can maybe write like 2 times x, whatever. But in theory, this will time limit exceeded because this is n squared, like I said. So yeah, so I'm very fortunate that's not in here, but that is definitely still wrong. But yeah, that's all I have for this one. Let me know what you think. What did I do last time? I'm curious. It is slightly faster, so I'm curious. Okay, so I did it kind of the same way, except for I called it up and bottom and whatever. This is more or less the same though. So yeah, it is faster. Who knows? Maybe just little random fluctuations. Yeah, that's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button. Join me on Discord. I will see you later. Stay good, stay healthy, to good mental health. Take care. Bye bye.